Rolling? Okay, let's take a look at, let's use that graph that we talked about, y equals 2 to the x, to graph a function that seems really unrelated to it, but there's a really good property that we're going to be able to use for that. So let's look at y equals 2 to the x and see how we can use that to graph y equals 1/2 to the x power. So let's take a look at the doc cam real quick and let's see what properties of exponents we can use to work through that one. So we start out with y to the 2x, and we're going to take a look how's that related to 1/2 to the x power. And again, something I made a big deal about earlier, but that seems like a trivial detail. Let's use the properties of exponents to take this x to both powers. So we'll have y is equal to 1 to the x power over 2 to the x power. As we talked about a little while ago, any power that you raise 1 to gives you an answer of what? Gives you an answer of 1. So we can replace that with just 1. So we have 1 over 2 to the x. What's another way we can write that? Well, 2's in the denominator, so we could use, again, those properties of exponents we talked about at the start. So our original function, y is equal to 2 to the x. Our new function, y is equal to 2 to the negative x. How are those related to each other? Well, first thing you're going to say, okay, that's a reflection. Now, is it a reflection over the y-axis or over the x-axis? An important question and easy to mess yourself up in, especially if you get the first part of this wrong. Are we doing the negative before we do the action of this function? In other words, when we raise 2 to the power, are we doing the negative before we raise the power or after we raise the power? Good. We're doing it beforehand, or it's a pre-function reflection. So is it going to be a reflection over the x-axis or the y-axis? Yep, it's going to be over the y. Question to you guys, how could we rewrite this? How could we rewrite this as a reflection over the x-axis? Okay, so now we have to do the negative after we do the action of the function, after we raise it to the power of 2. So to do it as a reflection of the x-axis, we'd have to put that negative in front. This would be a reflection over the x. Okay, let's go back. Let's take a look at how we could graph that. Let's look at our function, and actually let's go back to the doc cam real quick. We'll go back to the graph here in a second. We flip back to the doc cam. Thank you, sir. So reflection over the y-axis. How's that going to affect what we talked about earlier? The domain, the range, the asymptotes, the intercepts. We reflect it over the y-axis. So just as a rough sketch, here was our original function that had an intercept of 0, 1. So we're going to reflect it through the y-axis. So we were going up to infinity as we went away. We were going up to infinity as x went to infinity. So we're going to be going to infinity as x goes to negative infinity. Then as x goes to infinity of our new one, the blue one, we're going to be going towards 0. So here's our original function in black, y is equal to 2 to the x. Here's our new function, y is equal to 2 to the negative x, which is the same thing as 1/2 to the x power. Let's talk about, again, the domain, the range. The domain, has it changed? What values of x can we put in and get an answer out? Still negative infinity to infinity. The range. Did that change? Nope. Lowest value we could get is close to 0, but never actually touching 0. Where do we go up to? We go up to infinity. Our intercepts. Because the range never actually hits 0, we don't have an x-intercept, but we do have a y-intercept. Y-intercept is 0, 1. And our asymptotes go at the same location. At y is equal to 0. Let's just test that out in a Sketchpad real quick. Let's go back to the computer, take a look, plug in 1/2 to the x power, which is the same as 2 to the negative x, and let's darken that guy in. So we see again, as x goes to infinity, we're going towards 0. X goes to negative infinity, we're going towards infinity, and with the same intercept at 0, 1. Okay.
Good.